All right, well, thank you for coming. And it's a nice small crowd, so we can definitely, I was gonna say, hold your questions till the end, but I think I could entertain questions as we go. My name is Melinda McKinney. I teach biology at Coconino Community College and introductory biology. I've taught anatomy and physiology and environmental biology. And so tonight's talk is really about looking at the organisms, the living animals is what I really want to focus on at the end for the time when we're going to be doing hands-on work. But looking at the bugs in the compost. So bugs is really not the correct scientific term unless you're talking about true bugs, which is an order of insects. But we are going to look at the basics of composting, an overview of why it's beneficial, and we'll go through the process. What I really want to do is have it be hands-on. So the composting, you may have heard of it. I'm not sure. Actually, we have a small enough crowd. So would you raise your hand if you've composted before? Okay. Okay, so half. So about half people. Okay. And so, all right, I will make sure that I don't assume too much here. So the overview for today's talk is going to be 20 minutes on the composting presentation. So I have a PowerPoint that I'm going to go over, and I'll talk about the basics of composting, what it is, what you get, the benefits for you personally and for our community and the planet as a whole, the characteristics of a good, healthy compost, that final product, what you're looking for, so that if you go through all this effort, you can say, am I going in the right direction? And then the creatures, so looking at the living organisms that are actually inside living and doing a lot of the heavy lifting as far as the decomposition of the work, okay? Then we'll do the analysis, so looking at the organisms. So I brought in organisms from the compost. I have a couple stages at my house, so I brought in some that would be around in the initial stages and then some of the compost later to see if the community changes. We'll talk about acidity, moisture, texture, nutrients, respiration rates. So these are all things that we can measure. So if you brought your compost, we can actually look at the acidity of it, see if it's neutral, if it's basic, if it's gonna make your plants happy. The texture, we'll talk a little bit about just that crumbly nature of a good compost when you're done, that humus, which is gonna be crumbly and have air spaces in it. And then I actually have a few respiration chambers, so we can measure the rate at which the soil will put it in a closed system and see the change in the oxygen and the carbon dioxide. So over time, it might suck up some oxygen, it might produce some carbon dioxide, and that's probably because hopefully there's some living organisms in there that are doing some of that work that are going to be showing us that respiration rate. All right. Okay, so, I was just gonna have this up in the beginning. So if you haven't composted before, there is a lot of details and there's tons of information on the internet, so I'm not gonna belabor any of the specifics here. There's a lot of options, and there's this really great flow chart, so I love flow charts, kind of seeing clear as this is, it's still a lot of stuff, right? So you start up there and you say, okay, you want to compost. Where do you want to compost? Do you want to, there's a fruit fly that got out. Where do you want to compost? Do you want to compost outside? Do you want to compost inside? Do you want to compost at your home? Well, if you would like to compost, but you don't have a garden, you don't have anywhere to do that, you can still drop your compost. You can still bring your food scraps and things and contribute to a community compost pile. So there are options there. And if you go through this, right, then you can figure out what you'd probably like to do in the end. So I'm not gonna, like I said, I'm not gonna just read through all those and go through all the details, but there are resources, and that's gardensthatmatter.com, and I think they have a really good overview of your options, okay? All right, so compost basics. What is it? How do people do it? What goes in it? And what do you get, right? So those are the basics we're gonna go over. So in the simplest terms, compost is organic matter So something that was alive, organic, in the terms here, I know we use the word organic a lot to mean no pesticides added now, but organic meaning it was once living. So organic matter is matter that was produced as the result of life. So a plant that was living, a tree that was living, an animal that was living, any of those things, once they die, right, they will decompose. Okay, so this is a natural process that occurs. Composting is just speeding that up. So we're helping do that on a local level, not trying to ship all of our stuff away to a landfill. Let's let it decompose naturally and utilize the diversity, the organisms that are around that can help that happen. Okay, so microorganisms are necessary to compost at a pretty fast rate. If you just left it out in the air, it would break down in chemically weathered, physical weather, but it wouldn't have this great acceleration. And the microorganisms are actually going to heat up that pile because they have all this metabolic energy, and that is going to help speed up that rate of reaction. In fact, you can compost, if you do it, chop everything up, add the right things together, in 2 weeks you can get really super dark black compost. That's on the very extreme end. On the high end, if you do it slowly over time, it can take 2 years. You know, if you just kind of put it in there randomly when you have extra stuff and turn it every once in a while. So it's a spectrum, right? So we're gonna have carbon and nitrogen going in there. So carbon and nitrogen are the things that are in the organic matter. So we are primarily carbon. I'm carbon-based, so I'm mostly carbon. Does anyone know the 4 elements that most living things are? 96% of your body is made up of 4 elements. Water, and what is it? What's in water? Hydrogen and oxygen, yep. What are the other 2 elements? Nitrogen, carbon, yep, those 4 elements. 96%, in some organisms, 98% of the living mass. So it's pretty amazing. We've got all these elements on the periodic table, over 100, but yet just a few of those make up all of these living organisms. So we're gonna primarily focus on carbon. Carbon is really gonna be the food for a lot of these organisms, the way that we like to eat carbon, carbohydrates, like a lot of pasta, right? These microorganisms are gonna use that as a food source, and they're also gonna need nitrogen to help that process as they build up proteins. Nitrogen is really important for living organisms as well, okay? Okay. All right, so how do people do composting? Pretty much any way you can imagine. If you dig a hole in the ground and pour some stuff in it, right, Ray? He's done anaerobic composting and cover it over. You don't even need a whole bunch of oxygen in there. There's microbes that will compost that for you, and if you go back and dig it up later, you can find that it's actually broken down, and it was just, what, you said a few stickers or labels? Chiquita labels from the banana later. So you can just dig a hole in your yard, put some stuff in it, cover it over with soil, and if you don't have a whole bunch of critters and you didn't put a whole bunch of meat in there, then you probably be pretty good for a while. You can have a tumbler. A lot of people get this. So if you put it in, you're gonna wanna mix it up pretty regularly. So this just expedites that process and it makes it easy. So you chop everything up. A lot of times with this, it's a smaller amount. So with these, sometimes you'll have maybe a garbage disposal type thing. You chop it up really fast, you stick it in here, and then every day you rotate that thing and you make sure it's wet. And then over time, like I said, within 2 weeks, you can get pretty nice organic matter. These guys are the biggest friends to composters. So these are earthworms. There's some different categories of worms. There's a little red wigglers, which they used to be sold for bait. I called the Lake Mary bait shop and they said, oh, we don't sell those anymore. They're too skinny, they don't fit on the hook. But they're really good for compost because they can work their way all the way up to the top if you have a big pile. And you can get those 1,000 at a time on Amazon. So some people do vermicomposting, which is primarily just using worms. And so they can do that indoors or outdoors. You can open up the bottom of your compost pit and just let your night crawlers come up in there and they're gonna help out with that. They're super good. This is what I have at my house, except it's not this nice, but I basically made it out of pallets. So I went and got some free pallets. And then I screwed them all together, and I have a couple 3x3x3 areas where once I do my initial composting, then I stick it in here, you get that mass, it traps the heat, and it expedites that process. Yeah?
I was saying the guy at the farmer's market with quail eggs has worms.
Yeah, okay. Oh, he does?
Yeah.
Okay, so you can buy them at the farmer's market. Oh, that's good to know. Thank you. Yeah. All right. And then some people, so this is anaerobic, some people actually put black plastic over it, does heat it up, and you get compost there. This is more like up in the upper right-hand corner. I do a first stage where I just dump it in there on a regular basis. One thing to watch out for, I was just up in Page for over a week. I left, and I have the compost bowl next to my sink, and I had some pineapple in there, and then I had coffee, and I came back, and we have so many fruit flies in the house. It's amazing. So yeah, so just be careful. You want to take it out regularly if you have a lot of fruit in there. Okay, so so I'm gonna try to go through this. So I only have 20 minutes for the talk, and then we can do a whole bunch of hands-on stuff. So I'm just gonna move through this. What do you put in there? You can put in food waste, yard waste, manure. This is a big thing that you want to put in. People have known this for a long time. The Native Americans put fish in when they planted their corn. So if you put in the high nitrogen, high nutrient excretions from animals, chickens have the best feces because it's basically a combination of their urine and the hard poop together, and so it's a really high nitrogen. But you can use anything for that. You don't have to use manure, but manure is a really good source of nitrogen, and it helps. There's lots of microorganisms in there. Some people choose to put in animal waste, animal products, bones. Some people choose not to. It depends on if you have raccoons in your neighborhood, if you want gophers to come up or moles to get into your pile. Sometimes they'll actually eat your worms too. So just gotta be careful about what you're putting in there. Of course, you don't wanna put anything that's toxic. Something I just wanna mention is if you put in a lot of yard waste and you don't have a super hot pile, make sure not to put in your weed seeds, because if you cut down all your weeds and they've gone to seed, you stick them in there and you don't heat it up to the high enough temperature to kill the seeds, then they will germinate. So then you'll have a whole bunch of weeds in your garden, right? So what do you get? You basically get very fertile soil once you mix that result of the compost, which is called humus. You take that organic matter and you mix it in with the mineral matter, that's the rest of soil, and you get really nice fertile soil. And there's a whole bunch of benefits to having that, okay? All right, so free soil benefits, free fertile soil, reduces pollution, solid waste, okay, we'll talk about that, increases biodiversity, and it's amazing. So these are the benefits of composting. So soil is actually pretty much mineral matter. So this is like the rocks, the hard parts of the soil, and then you've got water in there. You really want to have you want to have the water around most of your soil particles. It helps dissolve the nutrients in there. So mostly you want it kind of moist. Compost is really great. It's like a sponge. It'll hold water. So whereas the soil, especially in this area, if it rains a lot, you get erosion, it runs off. The compost will actually hold onto that because of the air spaces that are in there. And when you add the compost, this organic matter right here, the 5% or more organic matter that you're adding to your total end product, then you're gonna have those air spaces, okay? So you want it to be this crumbly product, okay? All right, so I always thought, oh, if I had extra scraps, I thought, well, I'll just put it in the trash because it's gonna go to the landfill, and that's gonna be good because it'll help have microbes in there and digest everything. Well, it turns out it's actually a really bad idea. It's 20 times more bad for the environment if you put your scraps into the landfill because of the byproduct. So it creates methane gas. Methane is a greenhouse gas, and it traps 20 times the amount of heat as carbon dioxide. So if you let your compost work and you have aerobic environment, you're usually gonna generate carbon dioxide at home, and the organisms are gonna respire, they're gonna produce that. But if you take your waste, it's shipped to the landfill, they drive it in a truck that's burning diesel fuel, and then they stick it in the ground, there's not oxygen in there, and so there's anaerobic organisms that produce methane. So really you're helping circumvent that. Okay, increased biodiversity. So 1/4 of all of the biodiversity on the planet is from soil. So soil is really important for biodiversity. Tons of fungus and other animals that we're gonna look at today. This is from the United Nations, right? It says it's really imperative, right, to ensure a productive food system. And there's a National Soil Day, or an International Soil Day. Okay, chemical cycling. So the planet before we were here and we made compost piles, things will break down on their own, right? So we want that to be a natural cycle. We want things to move through the environment. So there's cycles for everything, right? Things don't just stay in one form. They break down, they fall apart, they're put back together. So we've got water cycle, we've got that's going through. What happens with the compost, what helps with the compost in the soil is that that compost is gonna hold onto your water. So you're not gonna need to water as much. And in this environment where it's so arid, that's really important, okay? So it's gonna help that situation and it will reduce evaporation. The carbon dioxide cycle, so this is what's contributing largely to the greenhouse effect, one of the major greenhouse gases. So carbon dioxide is part of this cycle, right? And so we're going to help keep that at a local level, and we're not going to add carbon dioxide to that cycle by trucking our yard scraps away, putting it into a landfill, and then actually going out and buying soil and bringing that home from who knows where that soil was created. So we're going to reduce carbon dioxide that way. And then the nitrogen cycle is another really important element or mineral. Nitrogen, again, carbon, hydrogen, oxygen, and nitrogen, those are the four main elements that are in us. So the nitrogen cycle is very important. Nitrogen is the number one thing you dump on crops, right? So it's the most limiting nutrient in most ecosystems. So you dump it on there, so most of our food is mass produced. A lot of that nitrogen fertilizer, first of all, that fertilizer is synthesized. That takes about 4% of the natural gas on the planet. Then you take it to your house, then you pour it on or take it to your farm or your house, you put the synthetic fertilizer on there, it rains, a lot of that runs off, and then you have problems as well with the runoff. So if we can keep this, the organisms that are involved on the local level, and the same thing's true for all these other elements. All right, characteristics. So we've got, what do we want in our compost cycle? If you're composting, you really want to think about, am I giving my compost organisms access to oxygen? They need to breathe. So if it's a microbe, you want to have usually aerobic respiration microbes, so you want to give them oxygen. So if you have a big pile, you can put PVC pipe in there and drill holes through it and let it aerate that way, or just turn it a lot. Make sure that you're actually exposing them to the air. Some places, if they do it at large scale, they actually blow fans through it. So just make sure there's access to it. You don't want to put it in a very tight container, close it off, and leave it. The odor should be earthy. That's primarily from a certain type of bacteria called Actinomyces. Acidity, usually, so there's a range on this. So some people say 6 to 8. So 6 is more acidic. 8 is on the higher, more alkaline, basic side. But there's more consensus if you're going to err on a side to be a little bit more acidic. A lot of plants are a little more acid loving, and so they'll tolerate more acidic environments better than they will basic environments. It does depend on the plant species. Moisture like a damp sponge, structure crumbly. You want to make sure you're putting in some microorganisms to start with. So you can put soil, like finished soil from your garden to start, finished compost from a friend, bring in some worms. So you're starting that off, so you're not starting from zero. And then for the temperature, you're gonna monitor that. And so you can get a compost thermometer. If you do, a lot of the composting where it's gonna work fast is gonna go up, and it's gonna go above 113 degrees is where you're gonna start getting a lot of that breakdown. So you wanna monitor it to make sure it's going high enough. If it goes too high, you can actually have spontaneous combustion of your compost pile and it can burst. So you don't wanna do that either. And if you turn that, that can help. If you put a variety of nutrients in, you're gonna have a variety of nutrients in your compost. So if you have all type of kind of varied diet and you put in yard scraps and all of those things, you're gonna get good compost. And the carbon to nitrogen ratio is something that they talk about, like making sure you have equal amounts, or not necessarily equal, but a good ratio of carbon, which are brown type of things, to nitrogen, which high nitrogen things tend to be more green. So the brown might be like straw. It's usually nitrogen poor. The green might be like spinach. Okay. All right. So I'm just going to fly through. Yep. These, because I really went over it and I just don't want to take up too much more time. So this is aerating, putting the holes into the compost pile so oxygen can get in, carbon dioxide gets out. You shouldn't have a stinky compost pile. If you do, you can add sawdust or leaves to cover it up. Usually that stink is because of ammonia is being produced, and that's actually a gas, and that's going to evaporate out. Okay, so you're losing the nitrogen. Often turning it can help. The pH, you want it pretty neutral or maybe on the acidic side. Again, if you brought compost today, we can measure your pH. The moisture, you want it as a damp sponge. So this is probably the biggest thing for us here in Flagstaff, right? It's not very humid here. And so the compost piles, if they are dry, those microbes are gonna dry out. It's not a good environment for them and you won't get that decomposition. So you have to water it. You may wanna insulate it a little so that your water is not completely evaporating every time. Okay. So crumbly, you want holes in your compost and ultimately in your final product, which is going to be your soil. You want it to look dark brown or black. The temperature, so here's a temperature. This is from Cornell, and they did a pile here where they turned it periodically. So these are days. So this is like, looks like 17 days or so. They're turning it. So the compost pile, if you chop everything up really fast and really small, and you put it together in a nice combo, you'll get a temperature spike. And so it's going up to 140. So they suggest not going over 140 to prevent sterility from killing off certain microbes. And then also if you go over that, you could also have a fire risk, okay? If you don't turn it, that's the graph on the top, where it's pretty much heating up and then cooling down. Okay. All right, so variety of inputs going to give you good minerals, and your carbon to nitrogen ratio, you can look this up online. There's tons of this stuff. Basically, it'll tell you want to target at the end about a 30-to-1 ratio overall as an average. So if you start, like some things are super high in carbon, 500-to-1 would be sawdust, wood, shavings. Chicken manure is going to be really high relatively in nitrogen. So you want to get a ratio of those, end up with about 30-to-1. 30-to-1. Okay. So you can look online and figure out what's carbon, what's nitrogen. It's usually brown and green. Okay. And then the critters. So this is really my favorite part, looking at what's in there. So there's bacteria, archaea. Those are single-celled organisms. There's fungi, which can be single-celled, like yeast, like in baker's yeast, but also mushrooms. Right? And then there's animals. And most of those animals, 95% of the animals on the planet are arthropods, and most of those are insects. So these are going to be the players that we're going to see today because they're visible, and they help with that initial chopping up process. So they chew and shred and break things down, and they're really great for biodiversity in terms of our local ecosystem. So we're going to, and these temperatures, as the temperature changes, the organism community is going to shift. The thermophiles like it hot, the mesophiles like it medium, okay? All right, so bacteria and archaea, single-celled organisms. When it gets super hot, you're going to see the organisms, if you were to look at that, shift towards the one you might find like in Yellowstone in those hot springs. But basically, you're going to have, this is the actinomyces. These are a lot of bacillus, bacteria. We're not going to look at a lot of these today because if you look at them under the scope, the best we would get would be this, which is pretty good if you love microscopes and you know what you're looking at, but you're really not going to see a lot of detail. So that's why I want to focus today. I got mostly dissecting scopes out here so we can look at that. Okay. All right, the next organism, the fungi. Okay, so this is going to be our mold and fungus. This is the root network, I shouldn't say root. This is the network below ground. It's an intertwined structure. A lot of people are moving toward promoting fungal, like high fungus gardening and associations between roots and fungus. And so one of the practices there is no tilling, reduce the tilling. It helps hold together your soil so you're getting less erosion. And so this is the substructure, and then those are the fruiting bodies, the reproductive bodies. Okay, and then we're into animals. So we have arachnids. Does anyone know how many legs on an arachnid? 8, yes, 8 legs on an arachnid. And if you count the legs on a mite, and I'm sure we're gonna find mites tonight, you're gonna see that they also have 8 legs. So they're actually in that arachnid family. So these are mites, they're really common. They're gonna be usually these light color and then this red color over here. And we may see spiders, they kind of get out of the way as fast as they can. So usually they're in the periphery. They're the top predators that are eating they help control pest populations. So it's good to have them. If you kill all your spiders, the things that they eat are gonna go out of control. So spiders are really good for that top level, okay? All right, you might see a lot of larvae today. So insects go through many stages. Some of those, the more recently evolved insects, go through larval stages and pupal stages. So they have this very cylindrical body. They basically just eat a whole bunch of things. They don't eat the same things and they don't have the same look as their adult form. So you might see a lot of these, say, what is this? I'm not an expert in this field. I'm not an expert in entomology or the study of insects, but they may be fly larvae, they may be beetle larvae. I think we got some big beetle larvae in one of these that we can look at. Okay. All right. All right, this is a cute, I was up in Page with a kids camp and I had a group of girls and they named this Bob. They're like, oh, there's Bob. There's Bob the springtail. This is very cute. So springtails are very common. They're in regular soil and they can become super abundant in compost. And then you guys see this? Have you guys seen this around here? These guys, they're very common. They're kind of creepy looking, but they do eat aphids, which is a good thing for a lot of us. Okay? All right. And they don't actually go in your ears. Okay, these are millipedes. They're actually really friendly. They're vegetarian, so you don't have to worry about them biting you or stinging you. They don't have 1,000 legs, but they do have quite a few. Each segment has a pair of 2 legs. Okay, nematodes. These are actually in the arthropod family because they molt. They're roundworms, and so they feed on bacteria and fungi. They release ammonium, which is a type of nitrogen that's really good for the process. This is an isopod. It's like a pill bug or a sow bug. These guys, probably familiar with those. These are beetles, right? So lots of beetles on the planet. Here's some earthworms. I really tried to get earthworms out of my soil today. I saturated it because they usually come up. If you're gonna add earthworms to your compost bin, it's a good time during monsoons. If you go out to grassy fields after it pours, they're gonna come to the surface. Why? They need oxygen, yes, they breathe air. So even though they're under the ground, remember, air is in soil, it's really important. So if it fills up with water, they're gonna start drowning, they're gonna come out and be trying to breathe. So there's different types of worms based on, well, there's different types of earthworms for composting. And then here is just a simplified food web, okay? So that's all I have for my talk, my presentation, and I do want to encourage you to come back. We've got more talks in the horizon, so that's not the right date, is it? July 16th?
Yes.
Is it next Monday? Oh, okay, so coming up next Monday. All right, well, right away. So next Monday we have a talk on computers. So if you're interested in the progression of computers and how they have evolved and what's currently where they're forefront, then there's a talk on that July 16th. And then we have a talk August 13th. One of my favorite people, Rachel Edelstein, she is an avid mushroom hunter. She works for CCC. She used to work for the Arboretum for many years, and she's very knowledgeable on the subject. So if she's lived in Flagstaff for many years, she knows what type of mushrooms to go after. So that should be a really good talk too. Okay, all right. Okay, so there's scopes out. Let me just tell you about what's around the room and what we'll do for the rest of the time. There are gloves up here. So if you don't wanna, and I would recommend that you don't touch any of the compost using your hands. So in my compost, I'm a vegetarian. I don't put animal products in there. So one thing about composting is you can put pretty much anything in there. You can put in animal products, you can put in manure. I don't actually have manure in mine, which I'm on the rare end of that because manure is pretty much number one thing you want to have in your compost, except for, this is a bag of what not to put in, and I put in here cat feces and dog feces. Don't want to put that in because it actually, pathogens for little kids can actually grow up there. Also, so weed seeds, pine needles, if you have tons of pine needles here, they tend to be acidic. They don't break down that well. So you can put them in. If you are, try to grind them up first or try to moderate how much you're putting in of the pine seeds. And then pine cones, these guys are gonna be, you probably have abundant of these, but they're also really hard to break down. So just in moderation or try to chop them up. You can get a chipper, they're pretty expensive, but that's a good option. Right, the pine cones do have seeds. Yes, but they're, yeah. So if you don't, you could have the potential of getting pines in your garden, but you can pull them out. So these are the scopes, mostly they're dissecting scopes, so we should have enough for everyone to have their own dissecting scope. And the way they work, there's a button on the base and the light will go either from the top or the bottom. So you can illuminate, probably for the soil that we're looking at today, you're gonna wanna make sure that the light is coming down from the top, right? And then one thing to notice is that the back of these microscopes, you can adjust the height. So if it's not coming into a focus, the most common problem is that you haven't adjusted this back height. So there's this like silver metal piece here, and you're basically gonna loosen that screw. You can move it up and down, and then you can tighten that again, okay? Then you can, so that's a big adjustment. And then you can do the smaller adjustments using this rotating knob on the front, okay? Right? And then there's also the oculars, what you're looking through here, these are magnification of 10 times normal vision. Once you go here, now you're gonna get either 1, which is just gonna still be 10 times, or you can go up to 3 times 10, 30, okay, all right. Oh, one thing, okay, so this is a very hot bulb. So especially for kids, do not touch this bulb here. It can burn you. I've seen big blisters actually. So right under here, it's a bright, hot bulb. Please don't touch that, okay? And then some of them have specimens already, or at least the containers. There's also containers up here. I've got, if you want to look at the compost, I've got several different options here. This is compost. You can see a lot of this is white. There's actually fungus in here. This is a typical type of fungus that will occur, especially at the extremities where it's a little bit colder or a little bit drier, even in your pot. It helps breaking it down. Fungus secrete digestive enzymes and help break things down that way.
I have a quick question about fungus. Is it good to introduce?
Mm-hmm. Yeah, you can introduce fungus, and they do have, so where did I put it? So they have this mycorrhizal inoculant. So actually some of the professors here at NAU have been pioneers in the field to realize that they actually really help many plants absorb additional nutrients because the fungus have really tiny hyphae that are able to absorb the nutrients that the plants can't get otherwise.
Maybe some